Assalamualaikum. My name is Azrin Ikhwan bin Muhammad Wahidin. Number matric CE210067. And this is my group mates, Nur Fashihah and Muhammad Ashraf. For the introduction, the process of numerical integration, often referred to as numerical quadrature, is used to make an approximation of a function, definite integral. It entails breaking the interval into smaller subinterval and numerically estimating the integral across each subinterval. The Simpson's rule, the trapezoidal rule, and the Gaussian quadrature and typical approaches, the accuracy, function smoothness, and computational capabilities all influence the choice of numerical integration method. It is frequently utilized in disciplines like mathematics, physics, engineering, economics, and computer science, where precise analytical answers are frequently unavailable or unfeasible.
Assalamualaikum. My name is Nurfasha binti Muhammad Rashid. My matrix number is CE210069. I will present for the part methodology. Numerical integration is used to determine a function definite integral. The curve connecting the three nearby points can be roughly estimated using techniques like the trapezoidal rules and the Simpson 1/3 rules, while Simpson's 1/3 rules yield more precise results. The trapezoidal rule accuracy rises as the size of the subinterval. The function was simulated using a MATLAB program. Comparison between simulation and manual computation were done to guarantee correctness. The paper analyzed the function relative inaccuracy and the result of Simpson 1/3 rules and the trapezoidal technique. Manual calculation trapezoidal rules. Okay, for the step 1, the interval AB is divided into n segments of equal length such as h equal b minus a divided by n. That's mean 3 minus negative 3 divided by 6 because n is 6 and the answer is 1. Step 2, insert the value of x when the interval is negative 3 to 3 and the value of I when n is 6 in the table. Then find the value of xi using the equation and put the value of x. After that, summarize the value of fxi. This is a table and the answer we got using calculator mode 9 is table, and the sum for the f0 is 0.0676 and for the fi is 1.3139. So step 3, calculate the approximation of above integrals trapezoidal rules formula, and the final answer is 1.3477.
Now for the manual calculation for Simpson's 1/3 rule. Given interval negative 3 to 3, bracket 1/3x plus 5 bracket square, uh, numerically with states equals to 6, n equals to 6. Okay. For the first step, the interval AB is divided into n segments of equal length, such as h equal to b over a, b minus a over n. So we put the uh, 3 negative bracket negative 3 over 6. We got 8. Now for the step 2, we got 8. We got 1. For the step 2, we insert the value of the x when interval is negative 3 to 3 and the value of I when n equals to 6 in the table. Then find the value of fxi using the equation that is given and put the value of x. After that, summarize the value of fxi. Uh, as you can see here, this is the table. So for the I0, we put the x equals to -3, fxi equal to 0.0625. For I1, x equals to -2 and fx equals to 1. For I2, x equals to -1 and fx equals to 0.25. For I3, x equals to 0 and fx equal to 0.04. For I4, x is 1 and fx is 0.0156. For I5, x is 2 and fx equals to 0.0083. And lastly, for I6, we got x equals to 3 and fx equals to 0.0051. Now, we need to summarize the fx1 for this column. We got 0.0676 and fx2 for this column 1.0483, and lastly for the third column 0.25 plus 0.0156, we got 0.2656. Lastly, for step 3, we need to calculate the approximation of above integral Simpson's 1/3 rule formula. Now for the formula, we got h/3 bracket fo plus fn plus 4 interval fi minus I plus 2 interval fi. So we put all the number. For h equals to 1/3 uh, bracket 0.06276 plus 4 times 1.0483 plus 2 times 0.2653, and from that we got the answer that we want, which is 1.5973. That's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Nasri, matrix number DE 2022. Okay, so for our group, we will do for trapezoidal and Simpson 1/3 rule. Okay, so for trapezoidal rule, our lower limit is -3, upper limit is 3, number of segment is 6. Okay, our H equation, B minus A over N, will be 1. Okay, so if not, this is the value we obtain for in manual calculation. Same with Fy. So this is the equation for trapezoidal. Okay, so when we run, okay, here we will get 1.3477. So our A is 3, B is 3, N equal to 6, H equal to 1. So X and Fx is we obtain same with the table. If not, Fy. Okay, and then since odd equal to Fy, so odd number is 1.3139. So the I value is same 1.3477 with manual calculation. Okay, so next will be for Simpson 1/3 rule. Okay, so it will be the same for lower limit, upper limit, and number of segment, and H value. Okay, so for F naught we obtain in the table Fy and Fz same we obtain from the table that we calculate in manual calculation. Okay, so for odd equal to 0, if equal to 0, and for I equal to 1, 1, and minus 1, odd equal to Fy, and 1 equal to 2, 2, and minus 2 even equal Fz. Okay, so for the formula, Simpson 1/3 will be this one, H/3 times F naught plus 4 times odd and 2 times even. So we will run the equation and we will get 1.5973. So this is our result. 33, 3, n equal to 6, h equal to 1. So x, fx, same with our obtained in the table. From table, f naught, fy, and fz will be same after we add from the table. So odd will be number of fy, and even is number of FZ. Okay, so this is odd, this is even. So the I value approximation of above integral is 1.5973, same with manual calculation. Okay, so for the conclusion, to resolve numerical problems such as predicting future values or summarizing data, numerical method can be utilized. The team employed numerical integration to solve a steady flow problem in this project. They used the trapezoidal rule and Simpson 1/3 rule technique, each of which has a different approximation value compared to trapezoidal rule, which splits the overall area into smaller trapezoids. Simpson 1/3 rule approximates the quadratic function yields more accurate result. The MATLAB program demonstrated that the trapezoidal rule approach delivered a more accurate result and had a bigger approximation value. The team discovered that performing calculations with software has more accurate than doing so by hand, and they were able to make effective use of MATLAB program's features. Okay, that's all from us. Thank you.